Good morning. This is Maylene Martinez Villegas, Chief Science Research Specialist of PHIVOLCS. And welcome to the DOST-PHIVOLCS InfoBit Webinar series for the House of Representatives. This webinar series is organized to raise awareness for geologic disasters. But before anything else, we would like to thank all of you for joining us this morning. And especially, we would like to thank the Office of Committee Secretary Donald Caballera from the House Office of Congressman Erico Aumentado, House Committee on Science and Technology. It is through their office that we are having this webinar. And we would like to acknowledge as well all the representatives from the various House committees, committee secretaries from Poverty Alleviation, Pasig City Parole Probation Office, Committee on Human Rights, Committee on Games and Amusements, Committee on Housing, and Committee on Southern Tagalog Development. Later on, we will update this list as we see kung ano na po ang mga nag-post sa ating chat. Maraming salamat po. DOST-PHIVOLCS will be conducting this two-day, half-day InfoBit webinar for the House of Representatives in partnership with the House Committee on Science and Technology. Sir, we would like to acknowledge si Sir, nandito po siya ngayon. Maraming salamat po. The first webinar today, October 14, we will focus on earthquake, tsunami, and volcanic eruption preparedness. And we will feature a lecture by our very own DOST Undersecretary Renato U. Solidum. He will tackle earthquake, tsunami, and volcanic eruption scenarios and how to prepare for this. And tomorrow, October 15, we will be having the second webinar, InfoBit. And this time, we will focus on innovations for disaster prevention and mitigation. This will include two important apps that we developed in PHIVOLCS, one to be discussed by Ms. Mabiling Kahulugan and the other by Dr. Leonila Bautista, who will talk about REDAS. And so please join us again tomorrow. For this morning, we are very happy. Busy po ang schedule niya, but he made sure that he is here this morning. Our special speaker for today is actually a geologist. He obtained his Bachelor of Science Geology from the University of the Philippines and finished his Geological Sciences Master's degree from the University of Illinois in Chicago, and his PhD in Earth Sciences from the Scripps Institution of Oceanography from the University of California in San Diego. He worked with Philippine Institute of Volcanology. He joined PHIVOLCS in 1984, and he became director in 2003. So you can see here it's a long history rising from the ranks. And up until February of 2017, he was appointed Undersecretary of DOST for DRR and climate change and assigned as officer in charge of PHIVOLCS in March 2017. But in 2019, he was designated as the Undersecretary for S&T Services. He is also a recipient of many awards, like Presidential Lincoln Vine Award, Civil Servant from the Civil Service Commission, and Professional of the Year in the field of geology from the Professional Regulations Commission, and Excellence Award for Government Service by the Philippine Federation of Professional Associations, and Presidential Career Executive Service Award by the Career Executive Service Board. So sa lahat po lang yan, ang masasabi ko lang po, siya po ay Philippine Institute of Volcanology and Seismology. Please welcome USEC Renato U. Solidum Jr.
Maraming salamat, Maylene, and thank you for that introduction. Maraming pong salamat sa inyong pagdalo. I think I've spoken several times at the House of Representatives, but of course this is the first time that we are doing this in a virtual mode. But I think this will also be very beneficial for us because pwede na tayong mag-attend kahit nasaan man tayo. The real issue is that we are facing a crisis, currently the COVID-19, but we should not forget that behind this background, the occurrence of large-scale natural processes or hazards and the climate change will continue. The pandemic may stop, hopefully soon, but we need to prepare for these hazards and also prepare for future epidemics or pandemics. So my topic today would be essentially preparing for large-scale geological events. As you know, hazards have different scales. Ang landslide po, minsan maliit. Ang sunog, maliit din. So these events can be handled at the local level. But when we talk of large-scale or extreme events, these hazards can actually not only kill a lot of people, but affect governance and business development in a region or in the country. Hence, although we actually operate at the local level, we need to make sure that the coordination efforts should be done at the national and regional level as well, because one cannot cope singly the large-scale events. So let me start showing my slides by looking at this picture. The landscape of the Philippines is very beautiful, but the beautiful places that we are familiar with would actually tell a story about Beauty and the Beast. Why beauty? If we now see it, like on the slide, we see the beautiful Mayon volcano in Albay, Taal Lake and Taal volcano in Batangas area, the Chocolate Hills in Bohol, the white beaches of Boracay Island in Aklan, the mountains in the Cordillera and the valleys there, and even the waterfalls in Mindanao like Maria Cristina, and all of the landforms in the Philippines are nice to see, but they originate from the occurrence of large-scale geologic events and the hazards that they have brought with. Volcanoes are brought about by volcanic eruptions that can be devastating. But the Chocolate Hills, the White Hills, sometimes turning brown because of the grass in summer, the white beaches on many places in the Philippines, from Hundred Islands, Panglao Islands, Boracay, and many other parts of the country, were actually due to one, large earthquake events. These white hills and beaches originate from corals that live below water. And these corals that became rocks later on are lifted up by faulting and large earthquake events. And the beaches are pounded by waves that can be brought by typhoons, storm surges, and tsunami. These Chocolate Hills of Bohol were shaped by weathering, erosion, flood, and even landslide. The mountains of the Cordilleras were lifted up by large earthquake events and curved by landslides, weathering, and the valleys are formed by flooding and erosion, just like the Maria Cristina Falls. So all of the land of the sea in the Philippines have a story about the dangers in the past, the beast, but we now actually enjoy their beauty. So our real intention is to make sure that we enjoy our lives here on the surface of the earth, the Philippines, but also be wary and be prepared so that when these hazard-causing events will come, we can live safely with nature and events. That is the gist. But right now, we are focused on COVID-19. COVID-19 showed us that there are many impacts and losses, like physical and mental health effects. We become either physically sick or mentally sick. And of course, we see a lot of lives lost. People are isolated. People are displaced from their house to quarantine areas. Hence, there is social disruption at the individual, family, and community level. Because of the quarantine operations, we have seen loss or interruption of public services, governance not at the maximum force, and other critical services, such as education, we're now doing it online, health, Not too many people are going to the hospital, and transport sectors have been affected because of restriction, simply for physical distancing. Business operations have been stopped. We see a lot of loss or interruption of other supplies and even food. And because of the disruption in the mobility of people and stay-at-home orders, we have seen loss of businesses or livelihood, or loss of revenues from business interruption. This would then lead into the disruption of our economic development, where our growth is projected to be low or in some other areas quite negative. And because of the desire to contain this disease, we need to spend a lot of money for response and recovery intended for other purposes. These are the impacts of COVID. But think closely how large-scale geologic hazards and even hydrometeorological hazards would impact our lives. This can be more than COVID if we don't prepare for this. The Philippines is prone to many natural hazards. We are familiar with hydrometeorological events like typhoons, storm surges, floods, and landslides simply because they occur more frequently than geological events like strong earthquake events, tsunami, and even volcanic eruptions. This year, though, the start of our response operations in terms of disasters focused on a volcanic eruption of Taal volcano. But last quarter of last year, we were too focused on the series of strong earthquakes in southern Mindanao in Cotabato, Davao del Sur area. Hence, these events will from time to time occur, whether we have pandemic or not. So we need to also prepare for this. Likewise, we are in the global warming stage. Shown are the data from Pag-asa, which shows that there is an increase in our temperature every 10 years by 0.1 degrees centigrade. So we are seeing an annual minimum temperature increase and also an annual maximum temperature increase. So data would show us that we are warming.
Hindi.
And hence, there will be effect on our hazards. It will exacerbate or amplify hydrometeorological hazards. Sedimentation and erosion at the coastal areas can happen, and these will affect our marine resources. More rain or more drought will affect our health, and hence will also affect the distribution or uneven distribution of water, will not only cause flooding but also drought, and would affect agriculture, water supply, and even our forests. So given this background, climate change, pandemic, these geological hazards and other natural hazard events would definitely be around. The big difference is that some are ongoing but slow onset, but some are sudden onset, like earthquake, tsunami, and volcanic eruptions are not so slow, but they will not be as frequent as hydrometeorological hazards. We have more than 300 volcanoes in the country. 24 are considered active, meaning they have erupted historically or erupted in the last 10,000 years. Only 10 are being monitored. Around 5 to 10,000 people have been killed because of volcanic eruptions and other activities in the past 400 years. Example events that some of you might remember would be the eruptions of Mayon volcano and the lahars at Wood-in-Su, the 1991 eruption of Pinatubo, and the longer-lasting lahar events that are still affecting other parts of Regions 3, and of course the eruptions of Taal volcano in January. But way back in 1911 and 1965, this volcano has killed more than 1,300 in 1911 and more than 260 in 1965, and none in 2020. In terms of earthquake events, we record at least 20 earthquakes per day. Around 5 are felt every week. More than 5,000 earthquakes are recorded per year. And out of these earthquakes for the past 100 years, 100 have been considered damaging. And among these, 40 generated tsunamis. On the right side is a map of the Philippines showing you the epicenters of earthquake events, and all the areas in the Philippines except Palawan Island will be the source of the earthquake or can be affected by strong shaking. There are many earthquake generators in the country. Some are offshore. These are shown or underwater. These are shown as white lines with teeth marks. We call those trenches. They generate magnitude 8 or greater earthquake events. Of course, there are still many smaller events that can be generated, but I'm highlighting the fact that these trenches can generate magnitude 8 or greater earthquake events that can cause damage inland and also generate tsunami. The red lines there are the different active faults crisscrossing the different parts of the country. And these can also generate large earthquake events. And since they're on land, can cause more severe ground shaking. Kasi nandun na tayo sa lupa, malapit na tayo doon sa earthquake generator. So given this information, earthquakes will be part of our lives. Recent earthquake events are shown in this slide. Let me just enumerate some of this. 1968, a magnitude 7.3 earthquake occurred in Aurora province, and this caused the Ruby Tower in Binondo, Manila collapse. So this is more known as the Ruby Tower earthquake. But as a result of this earthquake, our Philippine Building Code was enacted in the early 70s. In 1976, a magnitude 8.1 occurred in Mindanao, in Moro Gulf, and killed 8,000 people because of a tsunami as high as 9 meters that arrived 2 to 5 minutes in Libak, Sultan Kudarat to 30 minutes in many other parts of southwestern Mindanao. And this devastation caused the creation of the National Disaster Coordinating Council in 1978. In 1990, a magnitude 7.8 earthquake occurred in Luzon, destroying Hyatt Terrace Hotel and many other parts of Baguio and Central Luzon like Dagupan. And because of this earthquake event, this affected severely Central Luzon and felt in Manila, and the following year, the eruption of Pinatubo. And this reminded the national government that we need to invest in really staging and monitoring geologic events. So after this 1990 earthquake and 1991 eruption of Pinatubo, the budget of VIIVOLCS somewhat increased. Recently, we have a magnitude 7.2 earthquake in Bohol. More than 200 people died. But if the same large magnitude earthquake event would occur in Metro Manila, the devastation and the death that we saw in Bohol will not be the same. It will be many, many times more. And last year, we had a series of at least 5 strong earthquake events, 5 magnitude 6 plus events in southern Mindanao, with a devastation of houses and buildings. And there we see, and of course in the past, that what we need for earthquake preparedness, one would be making sure that we follow the right construction using the right materials, right design, and the right workmanship, the need for proper land use and the coordination among national, local, and families and individual at the community level. So if we look at all these natural geological hazards, we will see that there are many other impacts beyond what we saw in COVID. I have underlined the impacts that we have seen in COVID, but I've highlighted the other impacts that we have not seen so far. Definitely, there will be life loss, more injury, physical injury for earthquake events, and also for volcanic eruptions or tsunami. We have not seen in COVID the damages to our buildings, infrastructures, properties, and equipment. But for earthquakes, even for tsunami, we will see this. Hence, the devastation will be more and longer lasting. Perhaps in the rural areas, this will not be very evident. But in big cities like Metro Manila, Cebu and Davao, and other cities, this will be quite felt. Hence, there will also be interruption of lifelines like water supply, energy or electricity supply. Transport systems like roads, bridges, ports, and airports will be affected, and even our communication will be affected. So, ladies and gentlemen, we will see far more disaster impacts than COVID-19 if you don't prepare for large-scale geologic hazards. So given this background, let us now look further into the future. What do we really want as a nation, as a community, as a family, or as an individual? The ideal state is that we will be resilient. Resilient means three things. One is be able to reduce the potential losses.
Pamainit mo, init yung dipin ko. Mainit.
We'll be able to reduce the potential losses before the hazard would occur. That is risk reduction. Be able to prepare to respond properly so that when the hazard is incoming, we will have an effective and efficient disaster response. So we need preparedness and response together. And lastly, if we're able to reduce the impact before the hazard would occur, and we have an effective response, we will not have a lot of recovery efforts. But still, if there are severe impacts locally, then we will have to have timely and efficient recovery. Right now, our focus is on response and recovery because we have not done so much on many risk reduction efforts that we need to do. But if we are able to do that, we will see that the Philippines will not only be a country known as highly prone to hazards, but also a country that can be resilient. That is our goal. The beauty and the beast story of the Philippine landscape will be there, but we'll be able to live safely within this hazardous environment from time to time. So the key actions that everyone would need to do at the national, provincial, local, community, family level are four. One, we should know the hazards and the potential risks. Ibig sabihin, know your enemy. We have to know what will kill us. Second, monitor what will affect us and forecast the possible occurrence. Now, for typhoons, we can do that. For volcanoes, perhaps. For earthquake, exactly when a strong earthquake would happen, we might not be able to do it yet, but we know the potential magnitude and the consequence. Given the information based on monitoring, on hazards and risk assessment, then we need to warn or communicate the information to everyone down to the community level. If we are able to do that, then we must ensure that given the right knowledge, we have to act on it by responding properly and timely. And this is where the various phases of disaster management would enter. Mitigation, strengthen your house, locate it in a safer place, prepare, how to respond, and how to recover. So given these key actions for disaster resilience, let me now focus on what DOST-PHIVOLCS is doing and where are the gaps that we need to address. And perhaps the House of Representatives staff will be able to look into how you would be able to address these gaps even at your congressional level or at the national level. So let me look at the hazard and risk scenarios. What are the threats to our communities? What will kill us? In terms of volcanic eruptions, we have many hazards that are shown in this slide. We have the flow of molten rocks down the slope of the volcano. We call it the lava flow. In Hawaii, you can see it moving very fast, but the speed of a lava flow in the Philippines is 1 kilometer per day. Although it's quite slow, no one should go close to a lava flow because rocks and boulders from the flowing lava might roll down and affect us. So lava flow is not a major issue as long as you have the proper distance. Asphalt is a major issue. One, because it does not only affect our health, agriculture, but it can even affect water supply system, Our transports, roads can be slippery, and most importantly, the aviation sector. That is why during the eruption of Taal, NAIA was stopped. In Europe in 2010, many airports were stopped because of a volcano in Iceland that erupted. So whenever we plan for airports, we need to make sure that these airports have redundant systems or other sister airports that need to be operational when a nearby volcano would explode. And ideally, then, we need to consider a possible volcanic eruption whenever we decide on where to site the airport facilities. The most dangerous hazard is the pyroclastic density current, or the downslope movement of materials, or the horizontal movement of materials across surfaces. Even water surfaces can be um, passed on by these surges, uh, and also the lahar. Pyroclastic flows or base surges are dangerous during actual volcanic events. We need to be away from the volcano, and for lahar events as well, after an eruption or during an eruption when rain would fall on loosely deposited materials. In a volcanic eruption, there are three major types. Phreatic or steam-driven explosion, when hot rocks would actually hit the groundwater seeping through the volcano. Steam-driven explosions or phreatic eruptions are common in all volcanoes, even if the volcano is at an alert level 0, meaning no magmatic eruption is foreseen in the near future. Steam-driven explosion can happen. So we need to make sure that people do not live on a certain zone away from the volcano. That is what we call the permanent danger zone. When magma is part of the eruption, we call it a magmatic eruption. But magma can be extruded out of the crater of the volcano slowly, non-explosive, not so dangerous, but most often it can be dangerous. The danger can cover in the immediate vicinity of the volcano or even tens of kilometers away. So we need to make sure that people get away from this dangerous volcano before the actual very hazardous phase of the eruption would happen. The third type of volcanic eruption that one needs to consider is the combination of magma and water, just like in Taal volcano. If you drink coffee and your glass or mug is very hot and you suddenly drop this in a cold water, the mug or glass would break. And so when a hot magma comes in contact with water, there will be fragmentation and very explosive eruption that happens in Taal volcano. That is what we call phreatomagmatic, or a combination of water and magma. So given these eruptions, we need to consider the various scenarios of the volcanoes nearby our congressional districts. Let's start with the sixth most monitored volcano, Pinatubo. We do not expect Pinatubo to erupt soon because the geologic evidence and studies indicate that the explosive eruption of Pinatubo would occur between 500 to 1,000 years. The only hazard that we expect for Pinatubo would be the lahars in the remaining active channels. But of course, we need to monitor Pinatubo because there can be small eruptions. But this will not severely affect many developments, especially in Clark Air Base or the new Clark City. The very dangerous volcano that we need to really prepare for, because it's nearby Manila, is Taal volcano. Taal volcano can exhibit various scales of eruption, from small stream-driven explosion. Hence, no people should live on the volcano island. It should be no man's land. But it can be very large, like the 1754 eruption, where deposits can be seen more than within 14 kilometers from the current Taal volcano. The 1754 eruption lasted for 6 months, and that was the scenario that we considered in January when we evacuated people within the base surge hazard map area shown on the right, and more than 200 people were evacuated. Unfortunately, no one died because of the direct eruption, although there were reports that some did not heed the evacuation or went back after the initial evacuation. Taal base surge is shown there on the middle screen. It's actually like this. Most volcanoes would erupt vertically, but since the crater of Taal is very wide, or sometimes the volcano uh, would erupt on the side, the explosion is not confined. Parang ano po ba yan? Parang may baril ka na mahaba at makipot yung barrel, malayo po ang tama nun, ang tatamaan, pero dire-diretso lang. Pero kung disabog ang baril mo na malawak ang bunganga, mas dispersed ang eruption. So in Taal volcano's case, sometimes the eruption is somewhat horizontal, and this would cause the very hot gases and rocks to move at more than speeds of 60 kilometers per hour horizontally above water and even cross the mainland. We have seen deposits go past the middle slopes towards Tagaytay of the 1754 eruption. So if we look into the Bay Search Hazard Map, more than 200,000 people will be affected. And if ever that happens, then many lands within the area can be devastated. Note that Taal town was formerly in Taal Lake before 1754. Now they relocated away from the lake. Likewise, the capital of Lipa and even Tanawan were on the lakeshore. They moved because of this eruption. For Mayon and Bulusan volcanoes, they can exhibit various types of eruption. Mayon is in Albay, Bulusan is in Sorsogon, from small steam-driven explosion to explosive eruptions beyond within the slopes of the volcano. Typically in Mayon, people are evacuated before the activities would start, and maybe at least 50,000 people are evacuated every time the volcano will act up. So although there is no death, the economic impact of these activities and of course the disruption to people's lives and economy will also be significantly felt. For the Canlaon volcano in Negros Island, this map is an old map, but it depicts to you the hazard that the area can be affected with. The pink there is the pyroclastic flow, the danger area where people need to be evacuated before the hazardous eruption would occur. And the yellow areas there will be the potential lahars, if ever there are significant deposits on the area. For the volcano in Mindanao, which caused the establishment of PHIVOLCS, or the Commission on Volcanology, Hibok-Hibok volcano, we see that the danger of pyroclastic flows are shown to be on where the actual Hibok-Hibok volcano is situated. So it's a dangerous volcano. It will affect one major town, Mambahao, just like what happened in 1951. So we also need to make sure that we actually prepare for this event. So those are the scenarios for the volcano. For earthquake events, people are so focused on looking where the faults are. Ang biro ko nga, siguro ang dahilan kung bakit focused ang mga Pilipino na magtanong kung saan yung mga active faults is because we are fault finders. Biro lang yan. And that is a good thing to know because finding where the faults are important so that we don't build exactly on top of it. That's the only solution from the potential rupture, is not to build on top of it. But the preparation for earthquake shaking goes beyond staying away from the fault, because the major hazard would start from the strong shaking when faults or trenches move. Because strong ground shaking can cause collapses of houses and buildings. These are not planned or constructed properly. Soft ground can liquefy, behaves like quicksand. Steep slopes can cause landslide. Ang biro ko nga, strong ground shaking can sometimes be better than a well-financed political campaign, because strong ground shaking will cause landslide. And strong ground shaking can be associated with fire. If the earthquake, on the other hand, would be offshore, there can be a tsunami. So we should not focus only on preparing for the faulting. We need to prepare for the shaking and the other hazards. And so, to just give you a background of what hazards we need to prepare for, let me discuss this in a little bit of detail, briefly. So when faults move, it can rupture the ground. It can move horizontally, like on the lower left, where the rice paddy dikes or pilapils were displaced around 6 meters, hindi na sila magkatugtong, or can move vertically, like in North Bohol in 2012, where the land rose on one side and subsided on the other side. Okay, the North Ball Fault is shown on the right. Rupture of the ground will essentially destroy anything on top of it. And ruptures are associated with magnitude 6 or greater events and can be of a few kilometers to hundreds of kilometers in length. All earthquakes are due when it comes to what we call tectonic earthquakes related to faults are due to movement of faults, but the movement will be very small if the earthquake magnitude is small to very large. So in essence, by knowing the length of the fault, we can also predict or estimate the magnitude of the earthquake that can happen in one area. The real problem is that earthquakes will not only affect areas on the fault or nearby the fault, but even hundreds of kilometers away from the source of the earthquake or the fault because of ground shaking. The ground shaking can be the up and down or sideways or rocking motion of the ground during an earthquake. And if the shaking is strong and maybe more than 15 seconds, typically we see a lot of damage if houses and infrastructures are poorly constructed. A strong shaking can be damaging if the earthquake shaking is felt at intensity 8. I will explain that later. But the longer the shaking, the higher the tendency for it to be of a large magnitude and can be devastating. If our houses are well built, no problem. But if the equipment or our furniture in our houses slide or topple down, we can still be affected. Ground shaking can affect infrastructures, pipes, electrical posts, and roads, bridges, ports, and seaports. When there is a strong ground shaking, soft ground will liquefy. Shown on the top right would be a cartoon showing sand grains, which are the gray spheres, and with water in between the sand grains, the blue colors. Before the earthquake, the sand grains are not so compacted. During the earthquake, the sand grains will be moving and will exert pressure on the water in between. The water will either get out vertically like a water fountain with the sand, or would move horizontally if the surface is covered with concrete or asphalt. In the end, there will be compaction on the ground, and anything on top of it, if not properly anchored, can subside, like the bridges or the buildings, and roads can be fissured, and buoyant objects like damaged or like gasoline tanks, like shown on the middle lower part, pipes, or even water pumps can rise above the ground because of buoyancy during liquefaction. And these liquefaction-prone areas are those areas that have very shallow water table with loose sediments, and these areas are the same areas commonly flooded during heavy rains. Nobody dies from liquefaction, but the physical impact on infrastructure will either render it unusable, or we need to replace this, or there will be interruption in the operations of the facility or of the transport systems. During strong shaking, steep slopes can also be affected by landslides. And as global warming is experienced and as we experience rains over our hills and mountains, if the heavy rains are followed by strong earthquake events or even middle or moderate-sized earthquake events, there can be landslides. That's what happened in Ginsaogon. And landslides can affect locally and bury houses and kill people. So in mountainous areas, landslides are a big problem during heavy rains and earthquakes. Lastly, I'll talk about tsunamis. Tsunamis can be small to large waves resulting from the uplift of the ocean floor during earthquakes, or displacement of water by landslides, by submarine volcanic eruptions, or a meteor impact falling in water. Now, in the Philippines, we had suffered from 40 tsunami events, and as high as 9 meters in some areas. So, what would be the scenarios? What are we expecting in case there will be earthquake in our different congressional districts or in Metro Manila? The rule of thumb is this. If we have a large earthquake in the trenches or offshore generators, these can generate magnitude 8 or greater earthquakes. The ground shaking will be of intensity 7 to 8. I'll explain later what intensity 7 to 8, but essentially, these are described as destructive to very destructive shaking. If, on the other hand, the earthquake is generated inland by active faults, this can generate magnitude 7 plus earthquake events. But since they are already inland, then the shaking that we will feel will be stronger. Intensity 8 to intensity 9 in some areas. So the range of our scenario would be we all need to prepare for intensity 7, more so better if it's intensity 8, it's scenario earthquake. The only area in the Philippines that will not be affected by strong shaking is Palawan Island, but they can be affected by tsunamis on their shoreline. So let me show you briefly some modeled earthquake events from the different regions of the Philippines, so you would see that we need to prepare for intensity 8 shaking. Mind you, intensity 8 shaking are very strong. You cannot stand anymore, okay, during the shaking. Okay, so since I'm discussing intensity, let me just clarify the difference between intensity and magnitude. The magnitude is the energy released when the fault will move below the surface. Where the earthquake starts is called the focus. We compute the magnitude. You do not feel the magnitude. You feel the intensity. This is now the effect or felt strength at the surface. The intensity can be reported by people on how they felt it or how they observed their environment. There can be also instrumental intensity. We have instruments around 100 in the Philippines that would record the shaking and data would be sent via internet to PHIVOLCS. We need to increase these instrumental intensities. So what is important is not the magnitude. What is more important is what sort of intensity will your place feel if there will be a fault, nearby fault that will move. Okay. So again, intensity 8 shaking is called a very destructive shaking. This is when you cannot stand, and you will see hanging objects swing violently, and unanchored furnitures might topple on the floor. Intensity 7, you can still stand, but you also see the hanging objects swing violently. Okay. Intensity 6, you see the hanging object swing, some water in containers also sway. You feel dizzy, but you can stand, no? So what we need to do is make sure that when I flash the different maps, try to see whether the area is colored red or yellow, okay? And those would be intensity 7 to 8, more on 8, okay? I cannot show all the scenarios that we have developed for all of the provinces because we don't have time, but my purpose is to show you and convince you that any area in the Philippines can be affected by intensity 8 shaking. Okay, so what is intensity 8 shaking? So you have an idea of what is it and how would you feel it or how would you observe it. This will be a CCTV clip in Kobe, Japan in 1995. They were transacting business and then they cannot stand. That's intensity 8. Fortunately, the building was properly constructed. It did not collapse on them, but they cannot stand and things were falling or moving violently. That's intensity 8. Sometimes if you're near the epicenter, you would hear the sound accompanying it. Okay, you're clashing of big rocks. So starting from regions 1 down to Mindanao, let me show you some of the scenarios. For an offshore earthquake in region 1, you see the reddish yellow area there. Those are 7 or 8. A fault in Cagayan would move. You see that's also reddish in the whole province. In Mountain Province, a magnitude 7.1. If we talk about regions 3 or 4A, once the Philippine fault in Infanta will move, we see the yellow, red areas there. If the central Mindoro fault in Mindoro Island would move, you see the yellow reddish area there. Those are 7 to 8 shaking. In Bicol, for example, in 1907, there was a magnitude 7.4 earthquake. Then you will see intensity 7 to 8 shaking in the Bicol Peninsula. In Panay, 7.4 earthquake in 1787 will render Panay to be shaken by intensity 7 to 8 shaking. But there was a magnitude 8 earthquake event, or 8.2, 8.3 in 1948. If a magnitude 7 or stronger earthquake in Cebu would occur, you will see region 7 shaken by intensity 7 to 8 shaking. Likewise, similarly, in Leyte, 7.2 earthquake, you'll see 7 to 8. Okay, so if your province is in green, I've just not shown the model there, but it can also be intensity 8 there if the nearby fault would move. So in the Zamboanga Peninsula, if there's a magnitude 8.3 earthquake in the Sulu Trench, you will see 7 to 8 shaking in the Zamboanga Peninsula, Basilan, Sulu, Tawi-Tawi areas. If on the other hand, we look at Caraga, yellow there is 7 to 8, reddish is 8, magnitude 7.4 earthquake in the Surigao segment of the Philippine Fault Zone can be devastating. In central and southern Mindanao, we have several scenarios which would show us that there can be intensity 7 to 8 shaking as well. So ladies and gentlemen, priority is we focus on stronger earthquake events. And our building code assures us that if we follow the right design, construction materials, and workmanship, pulidong pagkagawa, intensity 8 shaking will not render our house or building collapse. There can be damage, but it will still save our lives. How about tsunami? Tsunamis have occurred in the Philippines, 40 tsunamis in the past. These are tsunamis generated locally, but there have been maybe 3 or 4 times when distant tsunamis from across the Pacific Ocean affected the eastern side of the Philippines. But in the Philippines, we have 6 major tsunami generators. The East Luzon Trough facing the eastern side of Luzon Island, the Philippine Trench facing Bicol down to Davao Oriental in Mindanao, the Manila Trench from Batanes to the Mindoro area, the Negros Sulu Trench from Negros Island down to Tawi-Tawi, and the Cotabato Trench in southwest Mindanao. All of these trenches are capable of generating magnitude 8 earthquake events and generate a tsunami. So if we summarize the tsunami threat in the Philippines, shown is a map of the tsunami-prone areas in the Philippines, color-coded. On the left side, the shorelines in red are those that can be affected by local tsunami and distant tsunamis from other countries. No? Pag merong earthquake sa Chile, for example, we don't worry about it in the western side of Luzon, Visayas, or Mindanao. The purple shorelines there are those that can be affected by local tsunamis, no? From the western side. While those blue color areas there would be affected by local tsunamis by either submarine faults or landslides. Okay? This happened in 2012 in Negros and Cebu. And based on historical tsunami accounts, we have seen tsunami as high as 9 meters in 1976. And based on our tsunami modeling, we have estimates of up to 12 meters in some areas of the country. If you want to know about the details of these are in the PHIVOLCS website, also in the Hazard Hunter app that we have developed and will be introduced tomorrow. Let me focus on how to appreciate the earthquake and tsunami scenarios. Let's take the case of Metro Manila. In Metro Manila, we have studied 18 earthquake scenarios. And out of the 2, we have found out that we need to worry about 2 scenarios. One is the magnitude 7.2 earthquake from the Valley Fault System that can generate intensity 8 shaking in Metro Manila and the provinces surrounding it, and the movement of the Manila Trench that can generate magnitude 8 to 8.3 to 8.5 shaking that can cause earthquake, that can cause shaking in nearby provinces and tsunami in the whole western coastline of Luzon, Mindoro, and Palawan. And of course, Metro Manila. So if we model the potential shaking of a magnitude 7.2 earthquake from the West Valley Fault, Then we see the red color there is intensity 8. The yellow color is also intensity 8. Okay? So it will cover Metro Manila, Bulacan, Rizal, Cavite, Laguna, and parts of Batangas. And those in greens are intensity 7 to 6 in Bataan, Tarlac, Nueva Ecija, parts of Quezon, parts of Cavite, Batangas, and Laguna. And I've indicated there where the current airports are, the Ninoy Aquino International Airport and the international local ports of Manila. And these are prone to ground shaking and also liquefaction, while the airport in Tarlac, like the Clark Air Base, are okay. So that's why it is important to have a Clark International Airport operational all the time. And if this earthquake will occur, we will see around 13%, 8 to 13% of low-rise to mid-rise buildings severely affected by the building, heavy damage or collapsed, and less or around 2% or less for the very high-rise buildings. If we consider slight damage of all the buildings in Metro Manila, we will see close to 1 million potentially damaged buildings. But what I have shown there are the heavy damage structures. In terms of casualty in Metro Manila alone, we expect 30,000 deaths if we don't do anything. And if the scenario is nighttime, there is difference between daytime and nighttime scenario. Because if the problem will be on the strength or resilience of residential buildings, so the risk will be higher if they are inside those buildings. But if it's daytime and if they're working, then the focus of the risk will be in schools or in offices. I think in offices and other commercial buildings, they're better off than many residential buildings because we have many non-engineered buildings in Metro Manila. There can be additional deaths by fire. But earthquakes do not affect only Metro Manila. It can affect the surrounding provinces. So if you look at the potential death from Metro Manila and surrounding provinces, we might see around 50,000. And if we add on the very serious injury, around 20,000 may be added into the death count. So ladies and gentlemen, the impact of a potential large earthquake in Manila will be more than the COVID impact. Because aside from the direct damage, we will see devastation of the infrastructure, which will have a greater economic impact and also effect on the governance. In terms of liquefaction, we see around 570,000 structures, buildings in Metro Manila to be affected by liquefaction to varying degrees. In terms of tsunami, if the Manila Trench would move at magnitude 8.3, shown is the modeling of the movement of a tsunami. It will affect not only Metro Manila, but the whole of western shorelines of Luzon down to Mindoro and Palawan. If we focus our attention on Metro Manila, our estimate of the highest tsunami will be close to 6 meters and will inundate areas further inland within 2 to 3 kilometers from the shoreline. And those areas are color-coded with the 5 to 6 meters in red. You can actually look at all the details of these different maps in the Hazard Hunter that I will mention later and also will be shown tomorrow. So given this scenario, we have a problem in Metro Manila for earthquake or for an inland earthquake or for an offshore earthquake. For tsunami, we have around 300,000 facilities or buildings exposed, and that would include the government buildings as well in the area. I mentioned this in Malacanang as well, that they are also prone to tsunami and other government offices. And around 2.4 million people, if they stay there in these houses and buildings, around 2.5 million are exposed, not necessarily to be affected and be killed by a tsunami. So, to help you in finding out the hazards and the scenarios, we have developed apps. One is the Fault Finder. You can just double tap the screen of your phone. It will tell you the distance of any house or building or facility or land to the nearest fault. So you can try House of Representative, it's around 1 kilometer. But if you want to know all the hazards, from hydromet hazards to volcanic eruptions to earthquake hazards, including tsunami, you can try the Hazard Hunter PH, which we also developed. PHIVOLCS led the development together with the other agencies, and you just double tap again the screen of your phone or computer. It will tell you all the hazards in less than a minute, and also you can look at the hazard assessment report and recommendation. You can try it. So that's the scenario. Now, given these important scenarios, we need to monitor and warn for this. So for volcanoes, out of the 24 active volcanoes, we are monitoring only 10. Okay? We have 6 volcano observatories for Pinatubo, Taal, Mayon, Bulusan, Hibok-Hibok, and Canlaon, but we have a seismic station converted also into an observatory monitoring Matutuman Parker. But Matutum Parker, Isarog, and Iriga are volcanoes with only seismic monitoring. And we need to also monitor the other volcanoes. What do we have? We have real-time data communication for the volcanoes that we monitor. This is a setup for Mayon. We have sensors on the slopes of the volcano, earthquake, GPS, IP cams, and infrared cams. And the data are sent via satellite and received, radio and received in the observatory in Legazpi, and via satellite to the main office. So we can monitor the volcanoes from a room here in Metro Manila in near real time. And we have experiences where we have several volcanoes acting up simultaneously. And aside from deploying people on the ground, we can actually monitor the activities from here. And we have a warning level for the volcano activities. So even though the volcano is considered active, it doesn't mean it will erupt soon. We have to focus on the alert level. So focus on the alert level if you want to know if the volcano will erupt soon. So the highest alert is 5 when the eruption, which is hazardous, is ongoing. But the highest alert for people to be evacuated is 4, because that is when the signs are present for a possible very large or dangerous explosive eruption. For Taal volcano, we only raised it to 4 because the danger was on the island and potential danger also on the mainland, but it did not materialize to the very devastating 1754-like scenario, thank God. There are currently 4 volcanoes which are on alert level 1, Mayon, Bulusan, Taal, and Canlaon. For earthquake monitoring, we have 105 station network. We started with 12 when we inherited the function of earthquake monitoring from Pag-asa in the 80s, but we need to put more. These are mostly via satellite sensors, data received here in the main office, and we can actually monitor very small events, but we need to set up more. If we compare the Philippines to Japan, for example, they have 300 main seismographs and more than 1,000 full complementation of seismograph. If you want to have more sophistication on the detection and fast communication of earthquake events, so we need more. In terms of sea level monitoring for tsunami, we have around 34 sea level detection stations via satellite and SMS communication, but we need to set up more. And we hope to add at least 10 more for this network. For tsunami warning and communication, we issue advisories and warning. For a tsunami as high as 1 meter, we issue a tsunami warning order where immediate evacuation of coastal areas will be advised. If the tsunami is less than 1 meter, we tell people to avoid the beach, stay away from the beach, and only those with houses very near the shoreline would go inland. We also emphasize the need for community tsunami warning and preparedness by using natural science for a tsunami. And for you to remember it, it's very simple. You remember the word shake, drop, and roar. Shake meaning strong earthquake, drop means unusual sea level drop, sometimes rise, but mainly drop, and the unusual sound when the incoming tsunami is nearby. We need to make sure that we immediately evacuate up to higher ground or to tall, strong buildings if in case the area is flooded. Lastly, how do we prepare for all of this? Obviously, we need to have plans, and we need to test the plans. And the plans need to be developed at the national, provincial, town or city, community, and family level. By knowing the hazards and the impacts, and by making sure that we have an evacuation plan and a preparedness and response plan. For businesses and government organizations, they must have business continuity or service continuity plans. During this time of COVID, you might want to know, how do we respond to an earthquake event? If there's a strong earthquake, then the earthquake protocol takes over the COVID protocol of stay at home. You still need to do the drop, cover, and hold and exit, but then you should not forget your emergency bag and put on your face mask if you have not done so. And we should walk briskly and not run and go to an open area where physical distancing is observed. If the area is too crowded, perhaps by families would be the guidance for distancing. We need to make sure that we have appropriate land use. It is good that Congress has passed the National Land Use Act version. Unfortunately, in the Senate, it's not done so, because this is important for disaster risk reduction. Example use of land use plan is making sure that there is restriction on building directly on top of the fault, at least 5 meters, because a structure can be destroyed if the fault will move. There also must be a focus on making sure that our houses and buildings and infrastructure are constructed correctly. There must be right design, right standards of materials, and right workmanship. PHIVOLCS has developed, together with the Association of Structural Engineers of the Philippines and Japan, JICA, a How Safe is My House questionnaire for houses made up of concrete hollow blocks from 1 to 2 stories. Because if we are not engineers or architects, even though we have advanced degrees, we might not know that there are certain standards for construction for our houses and buildings for earthquake, shaking, and strong wind. And since these are not taught in high school or even in college, unless you're in engineering or architectural class, many Filipinos do not know how safe are their houses. So we have developed this. 12 questions, and there you would see the minimum sizes of hollow blocks and reinforcing bar and the design of the house that you need to use. Try this. My message is we need to make sure that we have the right design and the right materials. We need to pass the Philippine Building Act, which is also in Congress, because this will enable the engineers, the architects, and other scientists, and the implementers on the ground at the local level to make sure that the houses being constructed are up to standards for these potentially devastating earthquakes of at least intensity 8. We also need to focus on community preparedness. Shown here would be the activities for tsunami, because tsunami community preparedness is very important for fast occurring earthquake and tsunami events. But we also need to do this in volcanoes, in landslide affected areas, and even for flood affected areas. Community tsunami preparedness must be done at the local level. Lastly, we need to prioritize the preparedness of the Greater Metro Manila area as well. Metro Manila is the seat of governance, business, finance. It is the location of the uniformed personnel of the government. It has like 30 million population, more than 1.3 million buildings, and Metro Manila, NCR, and Region 4A comprise around 63% of our gross domestic product, the largest share of the country's economic development. But we have seen that there is a potentially devastating earthquake that can happen, magnitude 7.2 from the West Valley Fault. Therefore, the main issue is how to do the preparedness collectively from the national to local level in a fast and effective manner. The President has approved through an executive order the two-pronged strategy towards an earthquake-resilient Greater Metro Manila area to reduce the risk in Greater Metro Manila area and enhance the resilience of Greater Metro Manila area and the rest of the country. The two-pronged strategies are subdivided into 2 columns in this slide. Let me focus on the reducing the risk. We need to decongest Metro Manila through dispersion of economic and business activities. Sustainability is an issue already because of water supply and the fact that the more population, the more buildings, the more investments that we pour in Metro Manila alone, we will have a very high risk. We have seen this in our COVID-19 pandemic. Our economy is affected because of the restrictions in Metro Manila. How much more, and surrounding areas? How much more if there will be devastation in these areas? We need to establish integrated regional government centers in more resilient sites. If a strong earthquake affects Metro Manila, we need to have a government center that can be used right away by national offices. Better yet, if we can also disperse national government agencies. We need to formulate service continuity plans to continue our job. Earthquake preparedness is not responding simply. Earthquake preparedness really relies heavily on making sure that our buildings and infrastructures are earthquake resilient. We need to have a good law. Our law is for building code is very old, 1970s, and we need to enforce these codes. For enhancing the resiliency, this is more on the response and preparedness side. What should be our key results for earthquake resiliency of Greater Metro Manila area? There must be multi-level preparedness at the national level, where massive retrofitting needs to be done at the public and private infrastructure, and training people on how to respond. We have identified regions to respond to Metro Manila, but they need to be capacitated. And that is why we need to focus on local response. We are on our own immediately after the earthquake. And this local response should also start from the household level. On terms of important things, we need to focus on water resiliency, food, shelter, power, medical health and psychosocial services, command and control, search and rescue, fire protection, law and order, and transport and mobility. These are massive tasks. That's why the President has repeatedly reiterated this in his SONA speeches. So ladies and gentlemen, let me end, since this is for the House of Representatives, some of my recommended actions. I have also presented this to our leaders. We need to make sure that we develop hazard and risk-sensitive land use plans. We need to pass the law. We need to have community-based preparedness involving LGUs and residents. And let me highlight, with protocols for preparedness and response depending on the hazard. Marami pong namamatay sa landslide sa ngayon. Kasi po kahit po maganda ang warning, kung wala namang response at the family and community level, meron pa ring mamamatay. This is very important. And this will also need the enhanced capacity building of LGUs to be done by many government organizations. We need to make sure that we have redundant communication systems down to communities. And one way of doing this, aside from what the government is doing, is involving local broadcast media, especially radio. We need to make sure that we have hazard and risk-sensitive infrastructure plans, especially for government buildings, for earthquake, making it more resilient. But we also need to consider the climate change scenarios and the consequences of disturbing our natural environment, like cutting off trees, cutting off or quarrying some of the mountains. We need to make sure that whenever we build on a particular land, whatever the design is, it might affect the potential risk of the structures. We should mainstream climate change adaptation in local plans. This is continuing. For the DOST, we need to continue improvement of monitoring systems. But of course, the concern there is if there will be enough budget support. For example, in this incoming year, DOST-PHIVOLCS budget has been limited, and we understand the reason. We're just stating that the development of more stations for both volcano and earthquake and tsunami will be slowed down. We need to improve the Philippine Building Code. There's a Philippine Building Act in Congress right now, so that we are able to improve the standards and the designs for our building and the materials that we will use. We need to educate people on safe construction for hazards, especially and for earthquake and strong wind. Kaya lang po, wala po yan sa school curriculum. Dapat tinuturo na yan. Focus on strengthening resilience of urban structures, where our economy will be severely dependent. Metro Manila, Metro Cebu, Metro Davao, and Iloilo, especially for earthquake event, and implement the Greater Metro Manila Resiliency Action Plans. Ladies and gentlemen, these are some of the things that I wanted to share with you, and I know that many of you can help us, help you and your families to be protected from the various geological hazards that we face. On the side of the DOST, we will continue to develop and promote science, technology, and innovation for a resilient Philippines. But from your side, we need to have support for new policies and laws that will really make sure that our efforts will be continuous and will be sustained so that all of us, ourselves, our loved ones, our families, and our countrymen are made safer despite the beast nature of our landscape. We can't continue to enjoy the beauty of our landscape. And when the beast mode happens in our country, we are able to respond effectively and properly and recover as soon as possible when we are impacted. Maraming pong salamat sa inyong lahat.
Okay, thank you very much, Yusek Solidum, for a very, very comprehensive discussion about geologic hazards sa ating bansa sa kabuuan. Before we proceed with the question and answer, I hope, sir, we have enough time for that. I just would like to acknowledge also, I will call yung mga names ng committees po according sa pagkakita namin sa chat. I'm reading this according to how it's posted in the chat, in our chat box. We also would like to acknowledge the presence of representatives from the various committees of the House of Representatives, Committee on Suffrage and Electoral Reforms, Aquaculture and Fisheries Resources, Agrarian Reform, Committee on Reforestation, Committee on Energy, Climate Change and Health, and Committee on Gender, Women and Equality, Committee on Committee Affairs Department Office, Committee on Human Rights, Cooperatives Development, and did I miss anything else? I hope none. Wala na po. Yes, thank you po for gracing tonight, this morning's webinar. And we have so far 3 questions I saw. Let's begin. From Committee Secretary Maria Lourdes Mendoza of the Poverty Alleviation Committee. To what extent have we implemented a wide-scale info dissemination or education of the poor sector on the barangay level?
Okay. For the information dissemination, in general, there will be many government agencies addressing it. The role of DOST-PHIVOLCS and Pag-asa are to produce the information and develop information materials that can be used by other organizations. From time to time, we have our own efforts to go down to the barangay level, but we cannot alone do this. So if we talk about the sectoral representations, our efforts are really on community tsunami community preparedness. But the massive education information campaign needs to be done and to be continuous. And we hope that the disaster risk reduction and management system really be operational. Because here we need to focus now on the role of the local governments in doing this. So there must be a hierarchy of sharing this information at various levels. And the DILG is promoting this, but the information dissemination or even warning down to the last mile is always still wanting. So kailangan po marami talagang tumulong dyan. NGOs are doing that as well, but to look into how wide the coverage is, my feeling is that it's not 100%. I'm not sure of the percentage. That is why I've been suggesting that at the NDRMC level that they need to be monitoring these efforts, both from the government side and the non-government sector. And I think the real issue is a platform on how to do this. That is why we have been offering to our technology for everyone to contribute. And I hope the OCD will take up the challenge, because the hazard hunter, Georis Philippines platform that will be discussed tomorrow is actually a platform not only for sharing hazards and risk information, but also to monitor projects for disaster risk reduction management, and even for other projects in government as well. And you might find it very useful for the House of Representatives.
Okay, thank you, Yusek Solidum. One question down. Marami pa pong kailangan gawin para po sa barangay level. We would like to acknowledge also the presence of committee secretaries and their representatives, Civil Service Committee, Committee on Housing, and Committee on Banks and Financial Intermediaries. Thank you po for gracing. Wag po muna kayong aalis kasi we will be having a photo shoot virtual after this. May question pa po tayo from Ms. Marilyn Manait. Especially in the light of the absence of regulation in the construction of buildings in socialized housing projects, strong regulatory functions of government agencies must be pushed. The building code, I think, is followed more in the breach, especially among these projects. How does the building code figure here?
Okay, the building code is very important, actually. We need to change it. That's why the Philippine Building Act is already in Congress, and I have attended some working group meetings. And the proposed law is very, very good. This has gone through many discussions already. And one of the issues that need to be addressed would be the socialized housing, where the limiting factor in some of the discussions was the amount. I think given the number of years when these laws have been passed, the amount would have changed already. And we feel that the standards would not be enough for some of the socialized housing. Implementation-wise, we have seen many earthquake effects in many places. I've seen this personally, that sometimes the hollow blocks being made at a local level, kung kukurutin nyo lang, masisira na. Kaya kung magpapakita na ikaw ay magaling na karatista, pwede mo nang gamitin yon. Wala masyadong pwersa, wasak na yung hollow blocks. Ganun din yung mga bakal. So implementation is a problem. And the law can be very good, but my other idea is implementation is only good if the regulatory organization on the local level will implement it, but they can only do so much. It is us, the house owner or the building owner, that really need to be part of the implementation. Because we do not know the basic standards of house construction. For example, sa maliit na bahay, ang minimum kapal ng hollow blocks dyan ay 6 inches. Pero karamihan dyan 4 inches lang. And ang minimum na bakal ay 10 millimeters in diameter. Marami dyan 6 millimeters. Perhaps nagtitipid. Pero una, dapat hindi na yan tinitinda. Pangalawa, kung makakalusot, dapat din, kung educated ka, hindi mo na yung bibilhin. So we really need to have a massive education on this aspect. And I'm saying that we need to introduce this thing in high school level. Bata pa lang sila, we have to inculcate that these are the standards. Now, for the building officials, I'm encouraging them to develop comics or designs. May issue nga na, syempre, ang nakaka-afford naman po talaga sa mga engineers and architects, yung pwedeng magbayad. So sa akin lang, maybe the DSUD or the local government building officials, mamahagi na tayo ng mga disenyo na approved by the engineers and architects. Libre. Although, mababa ang kita nila. Pero, I mean, that's the way to go. Because there are many non-engineered buildings. At kahit po nga, minsan sa Metro Manila o ibang lugar, meron namang nagpapagawang bahay na hindi naghingi ng permit. So, hindi na yun makikita ng building official kasi ang tinitin lang nila yung humihingi ng permit. So, there are many issues. And for me, this is done by passing the law, the regulatory bodies that will implement it, but we also need to have a very good foundation among our people by educating them properly.
Okay, thank you, Yusek Solidum. I hope nasagot po ang inyong tanong, ma'am. Another question, sir. From the Committee on Poverty Alleviation, ComSec Maria Lourdes Mendoza. In the absence of a law on building standards, how do we immediately remedy the problem of building structures, especially houses on poor communities that are built according to safety standards? Connected po sa kanina nyo na
Okay,
question.
there is a law. There's a law. The law, though, is old, but when it comes to engineering standards, the engineers know the better solution. Unfortunately, many may not be aware of this. No, so yun po yung suggestion ko na those that are involved in housing and focus on the poor should really implement the design well, despite the absence of the law. Kailangan talaga na yung standards would be implemented. Second, and major issue to, the availability of hollow blocks and, of course, the reinforcing bar will be another stumbling block. That is why in a briefing after the Mindanao earthquake events, we have suggested, and the President has announced it, that DILG and DTI and DPWH should make sure that the hollow blocks being developed in the communities are also evaluated. Malaking problem yan kasi maraming backyard na yan industry. But we need to now go down at that level to really help also the industry. Maturuan din sila ng tama, no? At maturuan din yung tao na pag ganyan hindi maayos na bibilhin. Ang message ko parati kung na-shortcut natin, nag-shortcut tayo sa disenyo or materials o sa workmanship, yung hindi pulido yung paggawa, shortcut din ang ating buhay. No? Again, these are my suggestions. These are not the work of VIIVOLCS.
Okay, thank you, sir. One more question, this time on tsunami. Wait po. How long would it take for tsunami to set in upon the occurrence of an earthquake? Mula po kay Ma'am Aline Ruth Vidal Villaluz.
Okay, ma'am, depende po yan sa lugar and depende sa shoreline configuration. Let's take the case of Metro Manila. If we take the case of the political boundary of Manila and the northern part of Manila Bay, it will take more than 1 hour, like 1 hour, 20 minutes maybe. But if we take the case of like Batangas, Cavite, 15 to 30 minutes, Bataan, mga 10 minutes lang. Mindoro, mga ganon. If the scenario is the Manila Trench and if the earthquake epicenter is in front of Mindoro and Bataan. But if we take the case of what happened in 1976, where the epicenter of the magnitude 8.1 earthquake was in offshore of Libak, Sultan Kudarat, ang arrival ng tsunami ay 2 to 5 minutes lamang. Ganon din sa Mindoro in 1994, 5 minutes. So it can range from 2 minutes to 5 minutes, very early po yon, to 10 to 15 minutes to 1 hour, 1 hour and a half. And further away from the shoreline, from the epicenter, and then mas matagal pa. So you will see now, based on the question and the answer, that sometimes technology cannot outrun or cannot beat the arrival of the tsunami before the warning will go down from the national to local level. That is why there is a massive effort, again facilitated by DOST-PHIVOLCS, to really have the local governments focus on community tsunami preparedness. So right now we have a 1-month series of community tsunami preparedness, tsunami summit for Mindanao. Kasi po we feel that at the community level, barangay level, konti pa lang ang gumagawa nun. But there are many good things already. Marami pong gumagawa ng ganyan. Prior po to the Typhoon Yolanda, nung nagkaroon tayo ng mataas na storm surge, Dr. Villegas, myself, and other staff of VIIVOLCS went around the area because we have talked to local governments about the possibility of very large earthquake and tsunami in the eastern shoreline of the Philippines. So we covered several provinces. In particular, in Eastern Samar, we talked to the provincial officials and the town mayors and barangays. And many had the pilot tsunami preparedness. And they were better off in responding to the storm surge because they have done a tsunami preparedness. So marami namang nakakita na na maganda doon, but we still need to again enhance preparedness at the local level. Let me just make sure that we all understand our role. We started all the preparedness for volcano, earthquake, and tsunami in the Philippines because no one at the local level and at the national level are really focusing on that. But remember, we are just part of a structure of governance. And we hope that by developing science-based protocols, guidance through pilot testing, then other agencies will now take over. So for example, after a series of discussion with DILG, they have done the barangay level tsunami preparedness using the Bureau of Fire personnel for some provinces in Eastern Visayas and some parts of Mindanao. And they need to be doing that. So marami pong gagawin. But we feel at the PHIVOLCS that we cannot just retreat from this going down to the barangay level. Our strategic plan is to really engage the appropriate stakeholders so that they are well equipped to go down to the local level.
Okay, thank you, sir. We are, I hope, okay pa tayo sa time. We still have some questions. From Ma'am Marilyn. Is a similar seminar going to be done? Pardon po, hindi ko po alam yung DHSUD.
They should.
They should.
Yeah, yung Department of Human Settlements.
Okay.
Urban Development.
Okay po. So she actually has 3 questions, magkakasunod. Similar seminar for human settlements and NHA, and then
Pwede
is tsunami.
gusto nila.
Yes, this one po is
This
in
is for the House
coordination.
of Representatives. Kasi request yan ng Science and Technology Committee.
Opo. Ni Sir Dax Caballero po ang kausap ng DOST para dito sa seminar na to. Then she asked, is tsunami automatic to happen after an earthquake? This is a clarification of yung
Not necessarily. Tsunamis can happen in several ways. So pagdating po sa earthquake-triggered tsunami, ito po yung kailangan. Kadalasan po yan dapat offshore, nasa tubig, magnitude 6.5 minimum, pero maliit lang po tsunami, but that's the minimum. And the ocean floor or the foot has moved vertically up or down to lift up the water above it. Kasi kung horizontal ang paggalaw ng lupa, walang tsunami mangyayari. So we already have identified which areas are most likely up or down or areas that are horizontal. Pero marami po talagang up and down. Second, the larger the magnitude, the shallower the earthquake. No? Pag less than 30 kilometers ang depth ng earthquake at mataas ang magnitude, pwedeng magka-tsunami. Okay? So, earthquakes of magnitude 7 or greater, lalo na kung close to magnitude 8, will develop more devastating tsunami. So sa DOST-PHIVOLCS po, we have developed 30,000 scenarios. Meron po tayong database for 30,000 scenarios for mga possible heights ng tsunami, so that we can actually develop scenarios for preparedness naman ng local level. Now, the other cause of a tsunami would be landslide. Kahit po inland yung earthquake, pero nagkaroon ng submarine landslide, pwede magka-tsunami. Take the case of the Mindoro earthquake, bukang landslide po yon, kasi horizontal po ang paggalaw ng fault, or nung 2012 earthquake in Negros Oriental. Nagkaroon po ng tsunami sa Negros Island and Cebu, eastern side ng Negros Island, western side ng Cebu. 5 minutes lang din po dumating na yung tsunami. Pero wala pong namatay doon kasi nga meron ng mga idea yung mga tao sa natural science for a tsunami. Bumaba po yung tubig pagkatapos ng malakas na lindol. So yun po yung mga possible causes ng earthquake-related tsunami. Earthquake-triggered landslide and motion of the ocean floor. So not necessarily lahat ng earthquakes sa dagat may tsunami, but we will actually assess if the particular earthquake generator or area can develop an earthquake that can trigger a tsunami. Ginawa po namin na.
Okay. Thank you, sir. Pero may follow pa din siya. Would mangroves help mitigate the damage caused by a tsunami? Because there are studies that show what mangroves do.
Yes. The answer is, short answer is yes. For the waves, both for strong waves, normal strong winds, or storm surges or tsunami. However, based on more detailed studies, the density of mangroves are important. No? Kung masinsin po ang mangrove, mas maganda. And there's another way of saying na maganda rin yung mangrove. We personally interviewed someone who's now maybe 50 plus years old, who was a survivor of the 1960 tsunami coming from Chile. And they were small kids then, they were playing on the shore. And wala pang warning noon, 1960 eh. And of course, walang earthquake. They were swept away. Mabuti na lang may mangrove. Sumabit sila sa mangrove. Nung bumalik na sila sa dagat, nasabit sila, so kumapit sila. So, yun. Na-save daw sila. So, one is destroying the wave. But if the wave height is more than the height of the mangrove, konti na lang, mababawasan ng konti, but not totally.